Hi everyone. So I think back to the project. So I'm presenting Sage today. Sage is a digital assistance for employees where you can ask HR queries and other kind of HR related policy related queries. Now, why I mean, before we go into the problem statement and all, let's just have a quick overview. We'll go through the problem, we'll identify the potential solution which is in form of this project, then the design and architecture, and then conclusions and future work. So now coming back to the problem, why what is this problem and why it is important. Let's take a persona, let's call it Dave. So Dave is a developer, is a software engineer who has been very good at uh, technology stuff, and he has just recently joined the organization, and he has been asked to go and meet some potential new clients. He has been told it in the morning, and he just wants to ensure that he can arrange his travel plans properly. He goes through the website, tries to figure out the policy for booking, lodging, what are the restrictions, what he should do, what he should not do. Spends a couple of hours, and after that, he's just banging his head trying to see things one link after the other. So this is a common problem. This is just one example. The other kind of things that happen is that you want to identify a particular thing, and these are not very complex queries most of the time. These are a lot of trivial queries. There are some complex things as well. For example, you want to have real-time information. We'll try to cover that as well. So now after establishing the problem, let's move on to the solution. Before we go into that, just to rephrase this, the core problem that we're trying to solve here is how employees and related stakeholders struggle to find specific information about an organization properly because of different reasons, distributed sources, not getting them organized properly, having things deeper down where it is not easily accessible. So the solution to that problem that I'm presenting is in form of a digital assistant, which we're calling Sage, and it helps employees quickly find answers to their HR and policy questions. Now, uh, now, how would we know that, okay, this is going to help us? So once we would be giving this kind of solution to the user, we would be trying to gather different kind of matrices about the engagement, about the quality of the feedback. Is that helpful or not? And we would also try to approach it from different kind of surveys. If we would also have to invest time into getting it in front of the user. So some kind of onboarding and other kind of things would help to utilize, help them effectively utilize this. Now, having gone through this, let's go through the application, how it looks like. Now, this digital assistant that we are having is a kind of agentic solution. When we say agentic, we mean that it can try to assimilate information from different kind of environments, depending upon different kind of questions and context. Now, in order to have this kind of system, we are a little mainly interested in two kind of data sources to start with. One is that static documents like policy documents and other kind of stuff, and then real-time information from different kind of APIs, which we can find from internal HRMS system. These are the kind of things that I would be simulating in this application and the project. The real system would have a replica of these things established into internal behind internal firewall or a system. So now, coming back to the solution, we are building an agentic RAG system. Here, we are going to utilize Snowflake embedding model and Meta Llama 3 model for developing this kind of RAG system. Plus, the same LLM model is going to be used for identifying tools. Now, one crucial aspect of this is that these models directly do not support very good function calling out of the box. So I have tried to simulate function calling via different kind of stages. So the way system looks like is when you get a question, the question goes through a specific kind of transition graph, and this transition graph is based on Lang graph, and this allows us to have our system in I mean behave in a controlled manner. So when you get a question, first we try to utilize a query router to understand which kind of question it is. It is a question that we can directly answer through a RAG kind of agent, or we can identify this question which require some real-time APIs. Just to simulate this behavior, I have divided it into two kind of systems. One is retrieval augmented question answer system, as well as a payroll system that we are going to have a look at. Once you identified the query, you extract the parameters. You call either the payroll node or the retrieval augmented QA node to retrieve the required information. In case of RAQA or RACA, it would be your documents that you have stored statically. In case of payroll and other kind of APIs, it would be the information that you have obtained from there. Once you have got that, then you are going to pass it to a node, or we can say generate agent, which would take this information, which would take your question, it would take your previous history and text, and based on it, try to answer. Once you have got answer, you return back this answer to the user. This is going to be the flow of our system. Here, just to simulate this system, I have designed a basic payroll API as a simple function rather than utilizing it out of the box. So now, yeah, moving ahead. So what is the stack that I'm using? Currently, this application is basically based on a chainlet application where LangGraph is the main core engine that is driving up the overall state transition graph. And I'm using fast embed for embedding module just because I intend to use it in production, and speed and latency is of paramount importance. Similarly, to rank the different retrieved documents, I'm using FlashRank, and here the model behind us is MS Marco for fast embed. The model that I'm using, Snowflake Architect. FAS is the vector retriever, and I'm using Grok LLM client just to simulate this system. Actually, I intended to use a Meta Llama 8 billion model. However, sorry, the only thing is that this was already free, so I thought to just utilize it. I have also one version of this deployed on a Hugging Face endpoint, and this whole app is going into Hugging Face spaces. Now, in a real environment where we would be putting into production, it would be our internal Kubernetes cluster where we would be putting this app together. Similarly, this whole application is talking to some external things, which would be your LLM model, which is as of now deployed on Grok endpoints, your internal APIs, which would be on private cloud. And we are using Langsmith as our tracing and evaluation engine. So yeah, okay. So this is the overall view of the application, how this application can help bring employee satisfaction and improve their productivity, because they would not be wasting a lot of time. It can also improve HR productivity, and they can use that time for something more important rather than utilizing answering specific trivial queries. While developing the system, I have tried to utilize some basic hallucination checks as part of the agent loop itself. They didn't work quite well. I plan to implement guardrails and more systematic evaluation going forward. Similarly, I've identified that these HR documents, whatever they are not that very common kind of terms often, because they have a lot of organizational terms. So fine tuning the embedding model as well as your LLM model on this data would be useful. In order to fine tune, we can use Raga's synthetic data generation to do that. In fact, we are trying something similar. The only problem is that the best thing that works out of that is so far OpenAI API, and you cannot pass the data to OpenAI API. So you have to do a lot of PII removals and other kind of things. After that, there's another problem which you find in all these kind of documents, that there's a lot of pretext, like there's a lot of indexing that is done in the early part of the document, which messes up your results completely. So I plan to clean up the documents in a manner so that it allows us to have only core parts of the system. You can, since these documents are already indexed well, this can be used for metadata indexing. So this is the overall system.